Hello, good morning, good afternoon. Welcome to the NNI webinar on U.S. government activities addressing micro nanoplastics issues. My name is Anil Patri from the U.S. Food and Drug Administration, serving as a moderator for the sessions on behalf of the Interagency Interest Group on Nanoplastics. It's a very active group with membership from 20 agencies and 100 members that coordinates these activities across U.S. government. We have recently hosted the first webinar on May 22nd from 7 U.S. government agencies that presented on micro nanoplastics research and funding opportunities. This is a second webinar in this series from regulatory agencies with domestic and international collaborations related to micro nanoplastics issues. As you all know, micro nanoplastics issue is an emerging topic of global interest with significant increase in research and public awareness. These public webinars are meant to showcase the U.S. government activities and collaborations in a condensed form and solicit input from individuals and organizations to collectively address these contaminants of emerging concern. Scientists from U.S. government agencies organized and participated in dedicated workshops, symposia, and sessions at conferences, and reviewed published literature to ascertain the status of science, potential human and environmental exposure and impact, and identify knowledge gaps towards policy development related to micro nanoplastics. There are many conferences. We all came together recently to get input from you all, from academia, industry, nonprofit, and other government entities. They, for example, include professional society meetings, National Academy of Sciences workshops, global summits, and APEC workshop that focused on Asia Pacific region to understand research and policy development in various countries, to collaboratively engage and address these emerging issues. I appreciate Jeff Holdridge and NNCO staff for providing excellent support to this interagency nanoplastics interest group and for helping us with these webinars. Now I'd like to welcome the excellent panel of experts today. Robert Wing, Deputy Director, Office of Environmental Quality, State Department. Kei Ho, Research Scientist, EPA. Stacy Wiggins, my colleague from FDA, who is a Senior Science Advisor, Office of Food Additive and Safety. Office of Food Safety and Applied Nutrition, or CFSAN. Custodio Muyenga, Environmental Health Scientist, and Gaston Casillas, Research Fellow, both from CDC, ATSDR. Mag Zarata Bermudez, Epidemiologist, CDC, NCEH. And Joanna Matheson, a toxicologist and program manager from Consumer Product Safety Commission. Please type your questions into the chat window during the presentations so that we can cover these questions during the panel discussions at the end. Now I will turn it over to Rob Wing from the State Department to present on galvanizing global action on plastic pollution. Rob?
Thank you, Anil. Thanks so much, and good afternoon, everybody. My name is Rob Wing. I'm the Deputy Director of the Office of Environmental Quality here at the State Department, and I'm going to talk about what we're doing in the international arena with respect to plastic pollution. And I should start by saying that plastic pollution in the work that we're doing internationally includes microplastics, and I think by extension nanoplastics. Again, really happy to be here and really honored to be on this panel. I think it's going to be a really interesting panel and look forward to all of the presentations. So I think maybe the next slide. I don't think I'm controlling the slide, so thank you. So as some of you may know, there is growing recognition, or maybe all of you probably know, there's growing recognition of that plastic pollution as a global problem, and it requires international cooperation. I think probably all of you have seen the videos and pictures and heard about all of the huge the garbage patches in the ocean that includes mostly plastic pollution. It's it's really garnered a ton of global attention recently. So yeah, it's a priority in several international fora. And in March 2022, the UN Environment Assembly agreed on a resolution 514, on ending plastic pollution and towards a legally binding instrument. And it launched negotiations on a global agreement on plastic pollution. Next slide, next slide, please. So I'm gonna talk a little bit about the, sort of the negotiations and the U.S. position in negotiations, maybe as an overview. And this is something that the U.S. was very supportive of. We were instrumental in getting the United Nations Environment Assembly, and the United Nations Environment Assembly is the organization that sort of sets the direction or sets the policy for the UN on environmental issues, and really provides the mandate for the UN Environment Program to do its work. And so it was a huge accomplishment that the United Nations Environment Assembly agreed on this resolution and launched these negotiations at the end of February, beginning of March in 2022. So what they've launched is something called the International Negotiating Committee, and that International Negotiating Committee will negotiate over the next couple of years a globally binding agreement on plastic pollution, on ending plastic pollution. The scope, and there's a resolution 514. The resolution lays out sort of the mandate and the scope of the International Negotiating Committee meeting, the International Negotiating Committee, and it's plastic pollution, including in the marine environment. And also, one of the things that the U.S. did, as part of this process, we submitted our views on I think the 13th of February, on what we think should be part of this agreement and the different provisions in the agreement, and sort of the direction of that we think the agreement should take. And as part of that submission, we clarified or identified that plastic pollution includes microplastics. So we expect over the next 2 years, basically, that there's going to be 5 negotiating sessions. We just finished the second one in Paris last week. So everybody, I was not there, unfortunately, but we have a whole team of people that were there, and we've gotten readouts on the outcomes of that negotiating committee meeting. Everybody is on their way back from Paris, or just back and recovering. So maybe the next slide, please. Thank you. So here are some of the outcomes from the first and second. So the idea is that after the 5th negotiating, or at the end of the 5th negotiating session, that basically the world, the globe, all of the participating countries will agree on a text that is a new agreement, or global agreement on plastic pollution. And so that's what this negotiating committee is working towards now. And as I said, there's been 2 sessions. We just finished the second session, and during the second session, we made progress on considering the details and elements of a potential global agreement. We requested that the secretariat for the INC, basically the organizers of the INC, draft instrument text, basically a draft text of the instrument that will move us forward and help us meet our goal of coming to agreement on the instrument, on the agreement, by the end of 2024. There's also a lot of stakeholder interest and engagement in the process, which we think is really positive. Next slide, please. So I'm going to talk a little bit about our approach to the global agreement, and what the U.S. position is with respect to what should be included in the global agreement, how it should be organized, and its ambition. So we are committed to negotiating a very ambitious and innovative and inclusive global agreement. I would say ambition. We all have the same ambition. We want to end plastic pollution, and we've talked about ending plastic pollution, and think the goal for ending plastic pollution should be, we should stop discharge or release of plastic into the environment by 2024. And we need an agreement that we really needed to be innovative and push and drive innovation and be inclusive, because governments aren't going to be able to do this alone. We're going to need to include stakeholders, civil society stakeholders, academia, the philanthropies, the private sector. We're all going to need to work together to really achieve this goal of ending plastic pollution by 2040. And we really need to jumpstart. We really need to get moving now. That's sort of the overarching vision that we're working towards. We think the agreement should include mechanisms to provide transparency, reporting, and monitor progress. Next slide, please. We think it should be focused on protection of human health and environment from plastic pollution. We think there should be a mix of obligations, that there should be binding obligations, there should be commitments and voluntary approaches, and really that everything should be designed to prevent and reduce the amount of plastic entering the environment. It should promote sustainable production and consumption. So the mandate, the negotiating mandate made clear that we're negotiating about the entire life cycle of plastics. And so that means, sort of upstream measures and related, and also measures related to promoting the sustainable production and consumption, increasing plastic circularity, strengthening management of plastic waste through nationally determined actions. We also think that it should allow for different solutions, that there's no really one size sort of like approach to this. We need to foster innovation and foster ambition. And we think the best way to do that is to allow for, different ideas and different solutions, and not necessarily have a one size fits all approach. Next slide, please. So one of the key provisions of the agreement that we think is very important are national action plans that will outline how each country is contributing to achieving the objective. And including how it will implement obligations on preventing, reducing, and eliminating plastic pollution. We really think that national action plans will foster ambition. Our vision is that there will be some common elements, and every country is required to do as part of the global agreement, and that the national action, that those should be included in national action plans. But then parties should also take additional actions or identify additional actions in their national action plans, really ambitious actions that allow them to reach the goal, as quickly as possible. We think these national action plans should be updated regularly and to demonstrate continued progress and increased ambition over time, and that they should be transparent, they should be public, and we need to promote transparency and understanding regarding the elements of national action plans, because that's going to foster ambition too and foster accountability. Next slide, please. And as I said in the beginning, we see a strong complementary role for partners and stakeholders. We want to highlight their actions to combat plastic pollution, and there is a call for in the mandate a multi-stakeholder action agenda, and we just actually started last week a group of friends of the multi-stakeholder action agenda, and we're really it's got to be a whole of society approach. We will need action from countries that are major producers, consumers, and plastic waste generators, which includes the U.S. We're the second biggest producer, and we're the first biggest waste generator, and we need to own that. We don't generate the most pollution. We do generate the most work and the most waste, though. So, and again, national governments cannot solve the problem alone. So next slide, please. And I realize I only have 1 minute left. So, so some of the things that we've done, we have a new science envoy in plastic pollution, Dr. LaShonda Corley from the University of Delaware. She's a material science scientist, and she's been traveling around the world and talking about some solutions related to material science. And she's a great addition to our sort of the plastic pollution the folks in our family who are committed to ending plastic pollution. And then the CEQ has appointed a new senior director for chemical safety and plastic pollution at the Council on Environmental Quality. He's focusing on making sure that the U.S. is doing everything it can to end plastic pollution. Next slide, please. And here is some of the outcomes from this last week from the INC. We had strong engagement from city governments led by the Mayor of Paris. We announced a new public-private partnership called EPIC, the End Plastic Pollution International Collaborative, to galvanize actions to increase circularity of plastics. And next slide. We also had stakeholder meetings in Paris, over 100 attendees from environmental justice committees, environmental NGOs, waste pickers, scientists, private sector participants from throughout the supply chain. And as I said before, we requested a zero draft text to inform negotiations at INC3. And, I wasn't there, but by all accounts, the US was instrumental in building bridges between countries with differing visions. We're sort of smack in the middle of the approach that of different what different countries' approaches are, and we're trying to really be a country that brings the different visions together. So the draft text will reflect options expressed at the INCs 1 and 2, and country submissions ahead of INC 2 for elements of an instrument. And I think next slide. I think I'm almost at the end. So then the next negotiating committee meeting will be in November. In Nairobi. Then there will be one in April in 2024 in Ottawa, and the last one will be in 2024, late 2024 in the Republic of Korea. And thanks much. I look forward to answering questions at the end of the session. And now I'm going to turn it over to, sorry, I took up 2 minutes. I'm sorry, but I'm going to turn it over to Kay Ho from EPA.
Thank you, Rich. So today, thank you for listening to this talk on the U.S. Environmental Protection Agency's micro and nano plastic research plan. I certainly can't fit everything into 10 minutes, and to that end, this presentation is a really brief overview on, oops, sorry, video, let me get the video on, there we go. Thought it was on, sorry. To that end, this presentation is a really brief overview of the ongoing and future research at the agency. May I have the next slide, please? I'd like to start with how the US EPA is organized. This is our organizational chart. Under the Office of the Administrator, there are 11 offices, and on top of it, there are 10 regional geographical offices that are not shown here. I'll start with the Office of Research and Development and the Office of Water, because that is really where the majority of the lab and micro and nanoplastic research is performed. I'll start with the Office of Research and Development, where the majority of lab and field research resides, and then discuss the very active program ongoing in the Office of Water's Trash-Free Water Group. May I have the next slide, please? To put things into context, 2019 is the first year that microplastics were incorporated into ORD's National Research Program. The objective of the program has been to develop and standardize methods to identify and quantify micro and nanoplastics in environmental matrices. And as we were just starting, we also wanted to build capacity in EPA labs nationwide for microplastic identification and quantification. Next slide, please. So I'll talk about the research that's been accomplished in the last 3 years, as I said, mostly method development. And I've organized these methods by environmental matrix, okay? I won't go through each one of these, but just hit the highlights as we go. And I'll start with surface waters. Dr. Anna Marie Cook, just before she retired, did the really hard work of pushing 2 standard practices through ASTM subcommittee. That's the standard practice for the collection of water samples and the standard practice for the preparation of water samples for identification and quantification of microplastic particles using a number of different identification instrumentation. In addition, Suhail Al-Abid in our Cincinnati lab, as part of making sure that we can have the capacity to look at microplastics across our different laboratories, was instrumental in pulling in a laser-directed infrared spectrophotometer. This is a high throughput instrument that's very new, and it's really key for us because it really cuts the amount of time that it takes to identify micro and nanoplastics, which is very, very important in the world of plastic identification. In terms of sediments, our Narragansett lab has focused on sediment method development. These sediment methods have been validated in EPA's National Coastal Condition Assessment Program, several regional sediments, and also in a round robin organized by the Southern California Coastal Water Research Project. Next slide, please. So talking then about drinking water and also the Southern California Coastal Water Research Project, which is a mouthful, so we say SQUIRP. We and a number of other people have been instrumental in developing these methods. And we've worked with SQUIRP to develop these drinking water methods that were mandated by the California legislature in 2018. California is currently working with analytical laboratories to develop an accreditation program for microplastics analysis based on these methods. Cheryl Hankins in Gulf Breeze has developed a series of methods to extract microplastics from coral reefs, as well as the effects of microplastics on coral reefs. And also moving along on the effects method, Marissa Giroux at our laboratory in Narragansett has developed an eRNA, eDNA metabarcoding workflow to detect the effects of community level impacts of nanoplastics to benthic organisms. Next slide, please. I always like to throw up a data slide, but of course we don't have time for a data slide. So I figured I would just put up this slide on the lessons learned that we have learned from developing all of these methods and publication and just learning how to work with microplastics. The first is that QA and QC are really critically important. You will always get contamination when you work with microplastics. And the key is that you have to be able to quantify that contamination. But the smaller the particle, the more difficult the analysis. The more complicated the matrix, again, the more difficult the analysis. And that prescribed methods such as developed in the Southern California Coastal Water Research Project may increase the accuracy and precision of these methods. Common spectroscopic methods such as IR and Raman are extremely accurate once the particle has been extracted, and that there is still work to be done to develop reproducible methods across laboratories. Next slide, please. So for future directions for ORD, we'll look towards methods for looking at smaller size particles, particularly in the nanoplastic phase. And we'll also move towards quantifying polymer concentration using instruments like pyrolysis GC mass spec, rather than particle by particle enumeration, which is done in the spectroscopic methods. Pyrolysis can give us polymer identification. It can look at the nanoplastic phase, which is really important, and it's faster, which is, again, key. We recognize that there is still a need for particle characterization. Pyrolysis cannot give us those particle characterizations such as color, size, and shape. And because these are yet early days, and we really don't know how things like particle shape and size can affect effects. We are starting to work on human health and ecological effects, and also have a project looking at microplastic fate and septic systems, and have a number of efforts looking at 6-PPD, 6-PPD quinone, and tire wear particles, looking at both the effects and how green infrastructure can change some of that exposure. Next slide, please. I'd like to switch gears here and talk a little bit about the Office of Water and their really active program that they have going. In 2017, the Office of Water Trash-Free Waters program convened an expert workshop to identify and prioritize scientific information needed to understand the risks posed by microplastics. They used a risk assessment approach to characterize these data gaps, and in 2022, they updated the data gaps. These data gaps can be summarized by their saying that analytical methods, although have advanced, still need to be performed for many complex matrices and especially nanoparticles. That source identification and factors that influence the fate of microplastics in the environment still need to be elucidated, and that toxicity evaluations with environmentally realistic concentrations need to be performed, as well as using environmentally realistic particles. In 2021, the Office of Water also updated and revised a method based on the 5 gyres protocol designed to help community scientists collect data on microplastic pollution along beaches and shorelines. Using this protocol, volunteers can collect important information that can be used to characterize current levels of microplastics and look for local, regional, and global trends. Next slide, please. The Office of Water has also, in conjunction with NOAA, has put out a United States federal plan to address microfiber pollution, and this is part of the Save Our Seas 2.0 Act. There are 5 major points to this plan. The first is to support, conduct, and fund research to address microfibers. The second is to prevent and reduce microfibers. The third is to capture microfibers in major pollution pathways. The fourth looks at minimizing microfiber toxicity and the hazards associated with microfiber pollution. And the last is centered around tracking, implementation, and sharing knowledge about the microfiber issue. Next slide, please. The Office of Water, which is super busy, has also convened a roundtable meeting for stakeholders to address challenges and opportunities that surround tire wear particles. The stakeholder discussion can be summarized by saying that they agreed that research was needed on almost all aspects of tire wear particles, that the research solutions should include a variety of approaches, including manufacturer reformulation or voluntary chemical substitution. And the stakeholders acknowledged the potential high cost of effectively dealing with the problem, but they also pointed out the high cost of not addressing the issue. And they discussed ways to effectively use funding. The stakeholders also discussed the usefulness of education as a tool for consumers and how cooperation at all levels of government were essential to solving this problem. And almost penultimately, there is a draft national strategy to prevent plastic pollution currently on the web. EPA seeks feedback on this draft national strategy. On the website, there's a series of questions we would like the public to consider during review and comment. There are 3 key objectives to this strategy. The first is to reduce pollution during plastic production. The second is improving post-use materials management. The third prevents trash and micro nanoplastics from entering waterways and talks about effective ways to remove escaped trash from the environment. This draft national strategy is open for comment until June 16th, and we encourage everyone to read and comment on this strategy. Finally, I would be remiss if I did not say that there is a Trash Free Waters monthly webinar series open to the public, and we can put all of those links in the chat. Next slide, please. The EPA has a small business innovation research program, which is designed to support small businesses to develop commercially innovative environmental technologies. This program has funded several projects that improve microplastic collection, quantification, and characterization. Next slide, please. My penultimate slide. And of course, to solve a problem this big, it takes a village. And these are some of our collaborations. I won't go through all of them or any of them, but be happy to answer questions about any specific of them. And finally, the next slide, the last slide. Oops, did I miss one slide? Oh, so maybe we missed one, but it was the slide. One more slide down. Oops. Well, it was a thank you slide, and the thank you slide had everyone's name on it. I'm so sorry I missed that. Of this great US EPA working group that without each and every one of them, we would not be able to do the work that we have done. Thank you very much. And with that, I'll pass it over to Dr. Stacy Wiggins from the FDA.
Thank you very much, Kay. Hi, everyone, and thank you so much for joining us today for this webinar. It is my pleasure to present today in the National Nanotechnology Initiative public webinar, and I'll be presenting on some of the high-level findings from our scientific review of microplastics in food that we conducted at the U.S. Food and Drug Administration, or FDA. Next slide, please. I'll start with our mission. The FDA is responsible for protecting the public health by assuring the safety, efficacy, and security of FDA-regulated products, including the nation's food supply. And this would include both domestic and imported foods that are in interstate commerce. Next slide. In 2019, we formed a work group at FDA on micro and nanoplastics in foods. We have a number of research and policy experts represented on the work group, primarily from the Center for Food Safety and Applied Nutrition. But given the cross-cutting nature of microplastics and nanoplastics, we're fortunate to have engagement across the agency on this issue, with representatives also from the Center for Veterinary Medicine, Center for Tobacco Products, National Center for Toxicological Research, the Office of Regulatory Affairs, and the Office of Policy, Legislation, and International Affairs. Next slide. One of the activities of this group has been to conduct a scientific literature review. So some of the topics that were included in our thorough review were polymer characteristics, plastic pollution, plastic weathering and fragmentation, micro and nanoplastics in foods, the potential health effects, and methodology. Next slide. Routes of exposure to humans in the literature included inhalation, dermal, and ingestion, where the route of exposure for ingestion could be through the consumption of foods and beverages, but also potentially from dust fallout in the environment. So for example, these studies looked at microplastics in the home or the kitchen environment where they may settle out onto the meals as they're being prepared. And then there could be ingestion of microplastics from other plastic products through oral exposure. At FDA, our literature review has focused on the ingestion of microplastics in foods and beverages. Next slide. So while we didn't have an exhaustive review, we did have a thorough review, and we found microplastics have been reported in a number of food commodities and beverages. And this, again, is not an exhaustive list, but we found reports of microplastics in seafood, bottled water, drinking water, salt, honey, sugar, beer, poultry, nori, milk, tea, soft drinks, and energy drinks. Next slide. And here are just some examples of some of the polymer types that were reported in different food commodities. So you can see, for example, that there's a wide range of polymer types in seafood compared to some of the other commodities. You can also see for milk, for example, the polymer types are polyether sulfone and polysulfone. And this indicated to the authors of that study that the polymers found in milk, in this case, were at least in part associated with the processing of milk. Next slide. So there are numerous reports of microplastics in seafood, and overall, there were more publications found for microplastics in seafood compared to other food commodities. There have been microplastics reported in a wide range of fish, mollusks, including mussels, clams, oysters, scallops, and snails, and in crustaceans, including shrimp and lobster. And these samples have been environmental in nature, but also some of the seafood samples were commercially relevant. We have, from the synthesis of our literature review, done a qualitative synthesis. However, it's really difficult to get at reliable quantitative data, and this has been due to challenges associated with methodology. And Kate just mentioned some of those. If we can go to the next slide, I'll just reiterate that throughout the literature review, we identified that many studies suffered from the lack of standardized definitions, the lack of standardized methods, or appropriate analytical standards. There were no standard reporting metrics. Many studies used methods that did not allow for characterization or confirmation of the presence of polymers. And Kate indicated in her presentation some of the types of methods that can be used for characterization and confirmation. Notably, we also found studies lacked appropriate quality control and prevention of contamination of microplastics in those studies. These methodology challenges, among others, have resulted in a lack of reliable quantitative data on microplastics in food as well as the inability to compare across studies. Next slide, please. And I'll point out that the National Academy of Sciences, Engineering, and Medicine also noted in 2020 that one challenge for microplastics is that there are different methods for detection, and some of them may not be appropriate or reliable for how they're being used to detect microplastics. Next slide. So when considering the potential impact of human health, we have to look at health risk. And the next slide. Health risk is a function of both the hazard and the exposure. And while the occurrence of microplastics in food and beverages has been detected and reported, we need a quantitative exposure as well as better hazard characterization to ultimately determine the potential health risk. Next slide. But in our review, we find that to lead to systemic conditions in humans, microplastics and nanoplastics from ingested food would have to be absorbed through the gastrointestinal tract and distributed to organs and tissues. And it has been summarized, for example, by the European Food Safety Authority in 2016, that particles greater than 150 microns in size are not likely absorbed by the human body. Particles that are less than 115 microns that may be absorbed have a very extremely limited likelihood of equal to or less than 0.3% of crossing the gut into the circulatory system. Next slide. One study published in 2019 examined human stool samples and determined microplastics in all of the 8 samples. While this was a very limited sample size, results did support the theory of microplastics being ingested. There was a different study in 2018 that claimed that more than 90% of the microplastics ingested are excreted. Next slide. At this point, toxicity studies on microplastics and nanoplastics effects are extremely limited, and the results are contradictory. Just pulling 2 examples from our literature review, you see an example on the left-hand side where the authors reported an indication of potential effects on energy and lipid metabolism, oxidative stress, and neurotoxicity. Whereas the example on the right did not observe any effects and concluded that oral exposure to humans of microplastics does not pose a risk to human health. Next slide. So from some of the high-level findings from our literature review, some of the conclusions include that microplastics have been reported in a wide range of foods. There are limitations, however, in being able to draw quantitative conclusions, and this is because of the extensive methodology challenges that remain. If we look at the polymer types that have been reported, we found that those in seafood have exhibited the greatest variability and mostly tend to be exposure to microplastics that would be in the aquatic environment. Whereas certain polymer types, for example, in bottled water and also, as I mentioned, in milk, indicate that they may, at least in part, be associated with processing and packaging. But ultimately, at this point, there is a lack of evidence clearly supporting that microplastics adversely impact human health. Next slide. There are, however, extensive knowledge gaps that remain, and this is true for microplastics, but I would say even more so the case for the smaller size of nanoplastics. We're lacking standard definitions and fit-for-purpose metrics. We lack standards and reference materials, standardized sample collection and preparation techniques, as well as detection methods. Kay mentioned real-world mixtures and also appropriate concentrations in studies, and I would definitely like to highlight that need, as many of the studies, and in particular, the limited toxicity studies, tend to focus on more of the pristine polystyrene spheres and at concentrations that appear to not be aligned with, what we're seeing from some of the studies in the literature. So that focus on real world mixtures at appropriate concentrations is really an area that needs to be filled. We also have knowledge gaps around accurate and quantitative data on the exposure from food, exposure estimates on a wider range of food types per plastic or polymer type. We're also lacking information on better understanding the fate and transport in the body, dosimetry, and the potential toxicity to humans. Next slide. So looking at the scientific literature is ongoing. Our work group continues to stay apprised of the latest science to shift any thinking that we might have as science evolves on this issue. A lot of our activities are working with our federal partners. So for example, participating in this US government nanoplastics interest group. And we've also worked with the State Department. You heard Rob give the presentation earlier on the efforts there towards a global position for plastic pollution. We're happy to participate in the State Department-led group. We've also been working with EPA. One example is by participating on the work that they did through workshops to develop the report on microfiber pollution as a part of our Save Our Seas Act. With respect to stakeholder engagement, federal engagement, we've had the opportunity within FDA to present at a One Health Today Show Forum. We've presented as a part of the National Academy of Sciences, Engineering, and Medicine Food Forum. And Rob mentioned earlier the new director for CEQ on chemical safety and plastic pollution. And I had the pleasure of submitting an invited brief on our scientific review on microplastics in foods. So these are just some of the examples of how FDA is engaged with our federal partners and the community at large. And with the next slide, I'd like to thank you for your attention and your interest. And it is my pleasure now to turn it over to my colleague, Custodio.
Custodio, would you mind unmuting your
Thank you.
Yeah.
Good afternoon, everyone. Thank you very much. Yes, my name is Custodio Muyanga, environmental health scientist with the Agency for Toxic Substance and Disease Registry. I'm sharing the time with Max Serreta, Bermudez, and Gaston Casillas. We will briefly update you on CDC's National Center for Environmental Health and the Agency for Toxic Substance and Disease Registry, Microplastics and Human Health Working Group activities. Next slide, please. Disclaimer. The findings and conclusions in this presentation have not been formally disseminated by the Centers for Disease Control and Prevention, nor by any agency of the United States government, and they should not be interpreted as the opinion or policy of any agency. Next slide. As I mentioned, along with my colleagues, I will give a brief update of the NCAH ATSDR Microplastics and Human Health Working Group activities. I will focus on the context first, and then exposure and health risk assessment, data gaps, and needs. Next slide. Our ATSDR NCAH interdisciplinary work group currently focus on microplastics and the nanomaterials. The work group wanted to better understand the occurrence of microplastics and nanomaterials in the environment, pathways, routes of exposures, and the potential health effects. Next slide. The vision of our work group is the following. Our science and resources energize communities and the institutions to stop harmful microplastics and the nanoplastics exposures in our environment. Next slides. We are fulfilling this vision through 3 strategic objectives. 1, define health risks. 2nd, constructive partnerships. 3rd, empower solutions. Next slide. So far, we have published and presented in local, national, and international conferences on human exposures and potential health risks. This slide shows an extract of 2 papers available in open literature, and the links are provided in the chart. Also in the slide, we have the links. Next slide. Preliminary results of our ongoing systematic literature review on microplastics in human specimens and biomonitoring data gaps and needs indicate that 1,000 human tissues and body fluid samples from nearly 5,000 people were tested for microplastics and nanoplastics. About 50 plastic polymer, microplastics, and nanoplastic types were identified and quantified in the human body. I concur all the major gaps and data with Stace Wigan, including methods, standardization, and exposure parameters, such as exposure duration, exposure frequency, uptake rate. Without that information, you cannot calculate just a simple internal dose, and you cannot estimate human health risks. Now I want to stop here and share and pass on to my colleague, Dr. Max Serreta Bermudez, to continue. Thank you.
Next slide, please. Thank you, Custodio, and good afternoon, everyone. Thank you for joining the webinar. My name is Max Zarate Bermudez, and I am an environmental epidemiologist with the National Center for Environmental Health. And today, on behalf of the systematic review team, I will present the status of our review on human exposure to micro and nanoplastics in water and potential health effects. This is an activity of the Microplastics and Human Health Working Group, which, as mentioned earlier, it is composed by scientists from both the CDC's National Center for Environmental Health and the Agency for Toxic Substances and Disease Registry. Our protocol was registered with Prospero, an international organization based at the University of York, England, that registers protocols for systematic reviews to ensure research integrity, transparency, and accountability. For those interested in learning about Prospero, please notice the hyperlink in this slide so you can be able to access to its website when the slides are made available, or you can Google it. Our review covers the scientific literature on micro and nanoplastics published between 1990 and 2022. We designed a comprehensive approach guided by the CDC's mission to protect public health and better understand how micro and nanoplastics, both engineered and incidental, as well as plastic additives, reach freshwater systems, enter drinking water treatment plants, and end in tap and bottled water and other water-based beverages. The scientific technological efforts being developed or implemented to remove micro and nanoplastics from water systems, the potential routes of human exposure to micro and nanoplastics in water, and the potential effects that micro and nanoplastics pose on human health, including effects on human cells being conducted at laboratory scale. Next slide, please. After searching A databases, we created an EndNote library of 6,472 scientific publications that met our search strategy. Covidence is an online platform to ensure transparency and produce reliable summaries of scientific knowledge. While uploading the EndNote library into Covidence, 55 duplicates were eliminated. Covidence follows a rigorous process that includes 3 stages. The first one, title and abstract screening. The second one, full text review. And the third one, data extraction. For those who are interested in learning about Covidence, please notice the hyperlink in this slide so you can access it when the slides are made available, or you can Google it as well. Before starting the review, we developed an inclusion criteria for reasons and exclusion, the inclusion criteria and reasons for exclusion used for stages 1 and 2. And 2 templates for data extraction and quality assessment used for stage 3. Our quality assessment template will allow us to select a smaller number of scientific publications that will be included in our final manuscript. Stacy mentioned the knowledge gaps that we are also finding during this review. For example, a standardization of analytical methods, including sampling protocols for different types of water. Our goal is to publish findings in peer-reviewed journals and present those findings in professional events. Thank you for your attention. I will be happy to entertain any questions you may have during the panel discussion. Now, my colleague Gaston Casillas will present his work on systematic evidence maps in which he collaborates with other ATSDR colleagues.
All right, thank you, Max. I'm going to share my screen now. All right. I just would like a quick confirmation that you guys can see my screen.
Yes, Gaston, proceed. Thank you.
Proceed. All right. Thanks, guys. Okay. Thank you, Max, and good afternoon, everyone. So back at the March internal meeting, we laid out the plans for an interactive systematic evidence map for the literature in the published scoping review that we published in 2023 January, so this year. I'm proud to announce that working with SRC, which is a contractor group that works with ATSD on other projects such as toxicology profiles, we together have developed the first iteration of this interactive systematic evidence map. This is still in the developmental stages, but this is a working demo for demonstration for today's purposes. On the screen, you'll see 3 interactive tables. Now, the main table across the top of the page has on the y-axis listed the 12 questions that we organized the scoping review literature categories into. Now, at the heat map, across the x-axis, we have the 3 main categories for the microplastics papers: adsorption and absorption, environmental category, and human exposures. The heat map itself is organized from light to dark shades, with a darker shade signaling a higher amount of papers in that question category. The only exception to this at the moment is the human exposure category. And this issue was a technical issue in trying to comply with 508 compliance. We had to choose 2 color palettes, and the Tableau coding makes it kind of difficult for both colors to go in the same direction. So you'll notice that 10 here, which is the highest value of papers we included for human exposure, it's the lightest value, and 1 is the darkest value. That's only in the human exposure section. But back to the heat map. So every individual cell in this heat map is interactive. So for example, if a researcher or a student or anybody was wondering, okay, what papers are available right now in the literature that have to do with microplastics behavior in the water and are paper absorption or adsorption. So you go to that cell and click the cell. Okay. So here's where the other 2 tables come into play. Once you've selected a box in the heat map, that question and category selection will populate the references table with all the literature pertinent to the question and category. The table to the right of the references has a percentage breakdown of the literature, and this will populate based on that question and category you selected. It's important to note this percentage breakdown can be used to further narrow down your search. For example, if you wanted just the reviews within your question and category selection, you would click the review value, and it will repopulate the references with just those reviews. In the references table, if you want to simply see the abstract and other basic information on the publication, you can just hover over, and it will appear where the mouse is located. For a more static view of the abstract, which will make it easier to read, you can actually just click on the reference. You can click on the reference, and it'll populate down here just the abstract. In this SEM, which is a systematic evidence map, we've also included all the DOIs to every paper in our study, which is over 500 papers. The DOIs are available and interactive. So again, you just click the DOI and you click the hyperlink, and it'll take you straight to that paper. It'll take you straight to the original paper. Okay. So that's where we're at right now. A couple of features we need to add immediately are one, well, this is a work in progress. We need a refresh button. So right now, the only way to refresh back to the original table is to click the actual refresh whole page, and that'll bring you back to the main table. We're also looking into adding another page that breaks down literature by year and category, which can be updated year over year with literature in absorption, environmental, and human categories. So it wouldn't be the full questions that we did for the system for the scoping review, but it would allow this work to continue being relevant for many years to come. We're planning on using this style of interactive systematic evidence map in future projects that the work group does. And we're hoping this work will reduce barriers to entry into the microplastic literature and help energize this growing field of study. With that, this demo is in the link on the slideshow, and I can share it in the chat. I'm going to stop sharing my screen now and give it back to Miss Jewel. Perfect. And so with that, I just want to say thanks to Custodia, or first of all, if you guys want to contact me, Custodia, or Max with any questions, on this slide, we have our emails. And so feel free to contact us with anything they can think of afterwards. Next slide, please. And finally, I want to say thanks to everyone on the microplastics working group. This is the whole team, and without everyone putting in their time and effort, none of these projects would have been possible. So thank you, everyone here. And with that, I'll go on to I'll pass the mic to our next presenter, Ms. Joanna Matheson from CPSC. Thank you very much.
Thank you, Gaston. So good morning, afternoon, and evening, depending on where you're joining us from. My talk will focus on interagency collaborations that have occurred underneath our nanotechnology program with that's relevance to the nano and microplastics. So next slide, please. So just very briefly, our agency is, it's a small independent agency. And our nanotechnology program actually began in 2008 under the leadership of Dr. Trey Thomas. So the next slide, please. So our laboratory, it's located in Rockville, Maryland. We lack the capacity to assess, analyze consumer products down into the nanoscale. So we have relied upon NEHI and the agencies that participate in it to partner with them in order to assess the hazards from nano-enabled products. So we have collaborated with all the federal agencies listed here, with organizations such as Terra and Versa for tox reviews, academic institutions like Harvard, Rutgers, University of Cincinnati, and Virginia Tech. And all of this work has been to focus on method and voluntary standard development. So for example, how do we detect and quantify the release of nanomaterials from nano-enabled products, as well as hazard assessment. So next slide, please. So from our first interagency agreement with NIOSH, that actually evaluated the release of nanomaterials from a cleaning spray. These collaborations have looked at the potential release of nanomaterials from product categories such as like sporting goods, clothing, personal care products, household goods, and for another one, electronics, which is where I'll focus my remaining slides on, which is on 3D printers. So next slide, please. So in early 2017, a report on emerging hazards from new technologies was released by our agency, so the CPSC, Consumer Product Safety Commission's program area managers. This was on emerging and future consumer products and technologies. And some of the ones they identified in this report were 3D printers and printed products, internet home-based smart technologies, wearable tech, new materials, which of course includes, and advanced materials and nanomaterials, VR, augmented reality, high-capacity storage devices. So the next couple of slides, next slide, please, sorry. So we're interested in 3D printing, and this is why it really worked well for collaborations, is the concern across the entire life cycle of this. So whether it's the making, the handling of the filaments, the printing process itself, the deposition of the emissions, the accumulation of house dust, waste recycling, cleaning the printer, printed products, post-printing modifications. This really is something that crosses all the federal agencies. So our concerns, you see these 3D printers in public spaces, whether it's a shared worker space, a library, a school, or even in the home. And when we talk about schools, I mean, they are in elementary school all the way up through universities. So next slide, please. So at the same time that our PARM report was released in 2017, one of our summer interns, Samantha Jackson, under the leadership of Ken Carlson, she had a project that modeled indoor air concentrations using published emissions data. And this data was actually taken from this 2016 paper. You probably can't see it, it might be a little bit small in your view, but it was from Parham Hazimi's paper because they actually felt that this paper had the most complete data set in order to estimate room concentrations. So I've just highlighted one piece of data, and this was actually presented at the Society of Toxicology. What they did is they modeled what would occur in a small home office setting. And then the model assumptions, which are listed here, included, for example, that there was continuous printing for up to 68 hours, that no VOCs, for example, entered the room with dilution air. But what they noticed, if you can see the figure a little bit there, and they compare, and by the way, they compared these to available health reference values, which in this case are TRVs. And these are actually California, the state of California's OEHHA values. And note, at the time that this was done, not even for maybe about 30% of the substances that were highlighted in the Hazimi paper, only a third of them had health reference levels. But the thing that what they saw is the model certainly showed that depending on the room ventilation, the room ventilation just strongly influenced the potential risk from emitted VOCs. And it literally would only take a few hours operation. So there's 3 different air change rates that you can see that are here with an And the middle one is the ASHRAE minimum standard, which I think is being updated. But when there is a low air change rate in that home, these health reference values were exceeded. And the example here is with caprolactam. So the next slide, please. So starting into some of the federal agency work that's been going on. And so what I'm going to be presenting is the work done by all these different agencies for us under interagency agreements. Here I'm just highlighting one particular paper, but this is coming from the EPA. This is primarily work that's been done on characterizing inorganic and organic constituents in 3D printer filaments from Todd Luxton's and Suhal Abded's groups at the EPA. So this particular paper is a recent one from Todd Luxton's group. And this is really much about method development, and it was optimizing the methods for extracting metals from ABS and PLA, so polylactic, sorry for the acronyms, polylactic acid polymers and acrylonitrile butadiene styrene. So I'll be using those abbreviations from now on. But what they noticed is that clearly the composition and the abundance of metals in these filaments varied greatly as a function of polymer, manufacturer, and color. And in particular, that makes sense since some of these metals were being used to impart color and, dyes to the filaments. Some of the substances are, they're serving as polymeric catalyst and some actually as flame retardants. But the analysis also noticed that, found that there are metal oxides and mineral and organic metallic compounds were present in the filaments. So Hall's group has been really working on, has had several publications, recent ones, that have characterized the VOC emissions and some of the formation mechanisms. And a lot of our different federal groups have looked at filaments that contain carbon nanotubes, because this is some of the things that we noticed early on. So they're comparing filaments that have carbon nanotubes and those that do not. And what Suhal's group saw is that the presence of carbon nanotubes in the filament lowered the total VOC emissions, but it also changed, though, some of the characteristics of those VOCs. So it elevated some of the more potentially hazardous VOCs. They've also looked at the influence of polymer additives on the gas phase emissions. Next slide, please. So at NIST, Keena Scott and Justin Gorham have been looking at the factors that relate to exposure to particle release during the 3D printing. So the printers that they've used are commercially available, they're affordable, and they're consumer accessible. And of course, this is why we are interested in this, because the cost of the 3D printers has come down quite a bit. So for example, NIOSH in a talk just a couple of weeks ago had a picture of someone's home who had 6 3D printers right there in their home office. So they assessed these printers and they evaluated the measured release of particles as a function of filament type, so ABS with carbon nanotubes and without, the emissions in proximity to the printer, the temperature of the extruder, and the filament storage conditions. So next slide, please. And so what this is demonstrating is that this is looking at the ABS, this particular one is showing ABS filaments that had the multi-carbon nanotubes. So they saw that the composite was releasing detectable particles, but the carbon nanotubes were either fully or partially embedded in the ABS. And just it's the proximity to the extruder and the filament type were really the only significant factors that were impacting the degree of particle release. And this is using FDM printers. Now in work that I'm not showing here, Justin's group has also assessed particle release and total VOC exposures from SLS and SLA printing devices. So we're getting beyond the FFF printers into some of the other types that are out there available to consumers. So SLS is selective laser sintering, and the SLA is the stereolithography. And what some of the preliminary data has shown is that the total VOCs measured in the SLS printer run were roughly a full order of magnitude less than that was seen for the SLA 3D printers. So the next slide, I also want to highlight another group at NIST, and this is this paper was recently published just last year by an international group, and it was led by Elijah Peterson of NIST. And this outlines the potential artifacts and control experiments for tox tests for nanoplastic and microplastic particles. It provides information on additional control experiments that are probably needed for these particular substances because they have some unique issues. For example, the plastic particles can float, or the potential for single cell organisms to be absorbed onto the microplastic particles. So this paper really reached across both human tox and ecotox, and really gives some excellent suggestions of additional steps to do when performing different toxic experiments, whether in vitro or in vivo. The next slide, please, is on NIOSH. NIOSH has published a series of published papers, and this has come out of Alex Stefaniak's group and Young Chen's group. They have assessed the toxicity of plastic composites, including ABS, PLA, and polycarbonate, so I'll call that just PC for now. In their in vitro studies, which is kind of like what I'm highlighting here, and this is a particular paper by Mariana Farkas, and there's been actually, she's had a couple now. This particular paper looked at the emission-induced toxicity to human small area epithelial cells. They looked at both ABS and polycarbonate emissions. They generated those emissions within a chamber, and this is a big thing that NIOSH has done is they've developed exposure systems and then they've used those exposure systems. So trying to highlight that a little bit. So in this particular one, the tissues were exposed for about an hour and a half. And what they saw is that both PC and ABS emissions induce cytotoxicity, oxidative stress, apoptosis, necrosis, and an inflammatory response. Short-term in vivo studies, though, didn't see that degree of effects. It was much more minimal and transient. So a little bit in the airways. So they're expecting that maybe there's this because an adaptive response is occurring. But some of the other studies, though, the PC filaments, so that was the ABS that had less. The PC, though, filaments did show some effects in neuroendocrine, to the central nervous system, and to the cardiovascular system. So Alex's group has done a tremendous amount in characterization of the emissions, but also going into measuring emissions in a college teaching lab. In particular, they looked at some of the factors that could be affecting some of the emissions. And in one particular paper, they demonstrated that hot temperature prints caused a big difference in the 81-fold differences in emission rates than compared to normal temperature. So it just, in that particular paper and some other ones as well, there's been the encouragement and clearly message coming across that in order to reduce the contaminant release, there can be hierarchy of controls. NIOSH has done this in some other work as well. So for example, either elimination or substitution, using polymers that different polymers, are using engineering controls, local exhaust where you can remove the contaminants, or isolating, for example, like in a school where more elementary students or middle school students isolate the printer from the students while it's running. And next slide, please. So this last one is just talking about some of the work that is continuing on 3D printers. EPA is continuing the work on characterizing the emitted particles, and in particular, what we're interested in is can these materials be accumulating in the house dust? And can you separate and determine which ones are microplastics versus nanoplastics? NIST is going to be continuing and looking at a little bit longer exposures, but also we're interested in looking at what's being released from 3D printed toys. So this would be looking particularly at for children handling them and mouthing this type of product. And for NIOSH, also they'll be continuing the tox work under different exposure systems. So different, looking at the biodistribution of the emissions within the tissues, and more work on the microvascular nervous system and hepatic, which we hadn't looked at so far, and potentially also whether it's going to be something that'll aggravate asthmatic responses. And also continue to work on communication of potential hazards of these, and also engineering controls. And the last slide, I believe, next slide is just a thank you. Thank you for participating in this. And I will pass this back over to Dr. Patry.
Thank you, Joanna, and thank you for the rest of the panel for excellent presentations. If you have not seen the collaborations, even during the first webinar, all these agencies are collaborating with others with expertise and resources, and that is apparent from these presentations. So if you have any questions, those that are participating, please type them in the Q&A window so we can get to those questions. I see a couple of questions already. And before I go to the Q&A and the panel, I have two more announcements. One is the availability of the slide decks from May 22nd webinar. So it is the link here has the slides that you can download from those presentations. And we will also post a video in the archive section from the NNC or NNI website. Next slide, please. And also we will post the June 6th, that is today's webinar, also will be posted in due course. And we recently had the 31st May and 1st of June. We had a NNI EHS research strategy meeting under the NNI NEHI. This is a public meeting, and we had excellent presentations from all sectors and stakeholders. So there is a document that is available for you to download, and if you have any comments, please post them. Again, the request for information that can be incorporated into the future strategy of Nano EHS. The deadline is June 16th. So please go to this site and then provide any information that you would like to be added. With that, I would like to go to the questions to the panel. The first question I have here is, what actions is the U.S. committed to if, as has happened with the PIC, POPs, and Basel conventions, we participate in the negotiations of a plastic treaty, but never ratify it? I would take it to Rob. Do you have any comments on this?
Sure. Yeah. Thank you, Anil, and thanks so much for the question. Yeah, we're committed to negotiating a global agreement that we can join, and that, as you may know, that's a pretty complicated question. We need to negotiate an agreement that we can implement, that we have domestic authorities to implement, and then there's a number of other processes that we go through after we finalize negotiations to determine whether it's something that we can join. One of the most important assessments is whether we have the legal authority to join. So we're committed to a very ambitious agreement, and we're committed to negotiating an agreement that we can join. I think I mentioned that we're the #1 producer of plastic, and we're the #1 producer of plastic waste, although not the #1 producer of plastic pollution. But we think it's very important that we are part of the global, the global solutions for addressing and for ending plastic pollution by 2040. So we'll need to negotiate the agreement, and then we'll go through a pretty thorough review of the agreement afterwards and make determinations as to whether we can join it based on the provisions in the agreement. But we're committed to negotiating something that we can join. So hopefully that answers the question. There's a whole range of, if you look at our submission to the process from February 13th, and you can find that if you Google it, the U.S. submission to the plastic pollution negotiation. It lays out all of the things that we have, our vision for what would be included in agreement, and all of those things that we've identified in that submission are things that we're committed to, and that if the agreement ends up looking like that, then that's an agreement that we, at least from where we sit now, we think we could join.
Yeah, thank you, Rob. I have a few questions that I think are more EPS centric, so let me go through one after the other. This is for Keho, if you can answer. We're a clean tech company that focuses on removing microplastics from waterways. We wonder how can private innovators contribute to the collaborative effort? Also, does EPA have any industrial partners on their working group?
Sure. Thank you for those questions, Heidi Median. I know that you put the first question up there, and congratulations on your clean tech company recent award of a NOAA grant, which can really put you right in the middle of looking at ways to remove, from what I remember, ways to remove microplastics from wastewater treatment plants. We've commented on your proposal, hope that strengthened it. And we also are looking, and actually Romel Nandi and I from Office Water have discussed any opportunities that we have seen for your company to move forward. And we will continue to see if we can have opportunities for that. Aside from those, reaching out to people, I would also suggest just being, continuing to be part of the plastics community, of which is a very strong, vibrant, and welcoming community, one of the most welcoming communities I've ever worked in, and people are always willing to help each other. So that would be what I would have to say about how you can contribute to the collaborative effort, as well as doing the excellent work that you're continuing to do in terms of removing microplastics from wastewater treatment plants. And the other one is, does EPA have any industrial partners on their working group? EPA has a number of different working groups, and they focus on whatever topic they happen to be on at that time. We have worked with the American Chemistry Council, which is the biggest, I'd say, working group of chemical manufacturers, and participating in their workshops, participating in their efforts to move research along, and also to just move the plastics problem along. And we work with them in what capacity we can. And I think it is a continual relationship.
Thank you. Okay, there is one more, maybe you could answer that, and then
Sure.
we'll go to the other questions. This is about the 6 ppd. Does EPA have any method development focus on tire wear particulate extraction from different media, that is water, sediment, and others, given the particular interest in 6 ppdq?
Yeah, 6 ppd is a very important issue that has come up recently, and we are actively working on that. We do have a project that is being headed up by our Corvallis lab, looking at green infrastructure and the way green infrastructure can remove those tire wear particles. Currently, it's just a laboratory focus, but looking how if green infrastructure barriers are put up, what are the best ones to use and how effective they are. And that research is just started underway as of 2023. Thank you for that question.
Thank you. There's a question to all the panelists. All of the panelists have stressed the problems caused by limited test methods, reference materials, and exposure, fate, and toxicity data. Is there a working group that is examining the extent to which methods, data from NNI's multi-year efforts can be used for examining nanoplastics, maybe microplastics? Maybe I can ask our CDC colleagues to maybe start on that. Custodio or Max?
I'm sorry, can you repeat the question, please?
So the question is the problems associated with the existing methods, right? So some of the publications, as the panel presented, are on polystyrenes, but then we talk about real world materials and situations, exposures. So we don't have the test methods, reference material, and exposure, fate, and toxicity data on these particles. Is there a working group? I mean, there is a nanoplastics working group, as I mentioned. This is an interagency interest group, formally not a working group, but it is composed of 20 agencies, more than 100 members, that meets once every 2 months. And we understand about what's happening within each agency and also internationally, and then coordinate these. And some of these collaborations came out of that effort. But the question is, data from multi-year efforts can be used. Can this be used for examining nanoplastics? Meaning, microplastics, there is more data. Is there something we can extend it to nanoplastics?
So I can start, and my colleagues can also contribute to that. I think everything depends on the quality. So as probably you may all have seen, we go through a systematic literature review. Usually the systematic literature review has rigorous methods on the quality control and quality assurance. And we throw everything in the process, but then may be screened through those exclusion criteria, depending on the quality. That is my very general answer. Thank you.
Thank you, Custodio. Any others, Kay?
Sure. Yeah, Daniel, I can complement
Max,
what Custodio mentioned. Yeah. I think Kay already mentioned in a few of her slides about these challenges, but also the development of methods for analytical methods for microplastics and nanoplastics. That is a knowledge gap that we all are aware of. And I think will be a combination of methods, one microscopic, including scanning electron microscopy, to not only determine size, but also determine shape. There is a group at Virginia Institute for Marine Science that has published some papers indicating that shape is very, very important in order to look at potential health effects in humans. Also, spectroscopic methods and combinations of GCMS, pyrolysis, that will allow us to not only make quantitative measures, but also qualitative measures. So, and I think this will be, once they developed, I think will be very, very helpful to the scientific community. And finally, I want to mention that with regards to microplastics in water, California is the first state developing standard methods for determining microplastics in drinking water. Thank you.
Thank you. Any others, Kay?
Yeah, I could just jump in a little bit about about a number of these things. So the NNI has served really as a really great clearinghouse for people to start to get to know each other, and many collaborations have come from that, and it has made I think our intergovernmental collaboration easier. I know that we have worked a lot more with USGS and are just more aware of what is going on among the different governmental agencies, because we're all so super busy, and we're all got our heads down and working, and then it gives us a chance to pick up and look around and listen, which is great. I think that in terms of nano, it is a particular challenge in terms of the methodology, but one of the things that we learned from one of the APEC meetings that Anil chaired just, I think it was last year, that in terms of nano, there are methods out there that we can use to look at nano, but they're very complicated methods. They are hyphenated, super hyphenated methods that are that need instruments that I can't even pronounce, right? And they work, but they are not quite ready for everyday monitoring aspects that we need to be able to start to look at and measure nanoplastics in the environmental matrices that we need to measure them in, and in the quantity of samples that we need to measure them in to get a handle on what is happening in the environment. But given that kind of sad thing, on the other hand, we can say that any measurements that we can get of nano in the environment are great, because even if they're off by an order of magnitude, it gives us an order of magnitude of what is out there, which we do not have yet. So it cuts both ways in terms of where we are in terms of methods. I don't know if anyone else wants to comment on that.
Yeah, thank you, Kay. Yeah, so we learned quite a bit from NNI work last 20 years on nanotechnology. So some of those methods and methodologies can be applied to nanoplastics, the submicron size, particulate, but then as Kay mentioned these incidental material, the detection, characterization, quantitation of these mixtures is quite challenging compared to the engineered nanomaterial, where you know what you're making and you know how to characterize them, you know how to quantify them. I think we have maybe one more minute. Let's go to another question. Maybe I'll give it to Rob. How influential are plastic corporations in the plastic reduction effort and intergovernmental negotiations? Rod, is there any industry?
Well, so stakeholders are very important in the process, but all stakeholders are very important in the process. The industry stakeholders, NGO stakeholders, academia, philanthropies, state and local governments, tribes. We are very inclusive. We want to hear from everybody, and everybody needs to be part of the solution. So generally, when we're preparing for these negotiation sessions, we hold stakeholder meetings, and we generally do stakeholder meetings with industry groups. We do stakeholder meetings with environmental NGOs. We do stakeholder meetings with state and local governments, and we do stakeholder meetings with tribes. So we spend a lot of time talking to stakeholders, and and during the negotiation session, we talked to we had I think 2 stakeholder meetings with in NGOs and with the private sector. So and included youth, and included indigenous groups, included state and local governments, included the informal waste sector and waste pickers. So we are very inclusive, and part of our motivation here is that we need all of the stakeholder groups involved, because everybody needs to be part of the solution here. We need to get everybody moving in the same direction so that we can solve this problem. And everybody needs to buy in to this, because everybody's going to have a role in implementing this new global agreement that we will hopefully finalize by the end of 2024.
Yeah, thank you, Rob. We ran out of time. So what I would suggest is there are a couple of questions that are not answered yet, but in the interest of time, maybe we could answer. Please send emails to appropriate panel members here if you have any questions, and then we'll directly answer. But there is a possibility to text the answers to the panel, through this window, if any of you would like to do that. There are some that are very quick. I can answer which government agencies are looking at airborne microplastics, indoor or outdoor air. I guess EPA and NIOSH to maybe start with, but I'm not sure. Kate, would you like to comment on that?
There we go. Sorry about that. Yeah. We are looking at, actually, we're looking at it more in drinking water than in air. But when we look at human and mammalian effects, we will start to look in air as well.
Okay. Any last minute comments from any of the panel members?
Just to say that, yes, I wanted to say that we are also have one paper that right now is under review with the journal, which focus on microplastics and nanoplastics in indoor and outdoor environment. So is one thing that we can also provide. But I don't know if that's all for right now. Thank you.
Thank you, Custodio. Again, thank you all. I wish to thank the panel and our colleagues from NNCO that helped organize these webinars and meetings for us, for the government agencies, and the excellent collaboration that is happening across the US government. Again, thank you.